Hello guys. Previously we explained that the electromagnetic wave propagation in Lossy media will suffer attenuation. That means when any electromagnetic wave propagate in any Lossy medium, its amplitude or its energy will be attenuated. Okay. So what's the meaning of attenuation? Or someone may ask, where the attenuated energy is gone, because according to the energy conversion law, the energy should be not disappeared. Okay, so part of this energy, let's just okay, we don't need this. Okay, part of this energy will be absorbed by the atom of the medium itself. So the electrons of these atoms or molecules or particles will absorb the electromagnetic wave energy and rise to high level of energy causing excitation of its atoms, okay, or its molecules or its particle. And according to the excitation of the atoms or molecules or particle of the media, they will be collided with each other. Atoms will collide each other and resulting heat. So the attenuated energy will be converted to heat, okay, by absorption by of the atoms or molecules or particle of the medium itself. And I think this is the big part of the attenuated energy will convert it to heat. Other part maybe will be scattered. Okay, what's the meaning of scattering? Scattering, its meaning redirect or reflection, but in different direction. So when the electromagnetic wave faced with particles or atoms or molecules, its size or its diameter in same order of the wavelength of the applied electromagnetic wave, okay, so this electromagnetic wave will be redirected in different direction or will be scattered in different direction, and according to that we could consider this energy is attenuated. Okay, so the attenuated energy is either absorbed, or the energy of the electromagnetic wave, which will be attenuated by the Lossy media. Okay, it could be either absorbed or scattered. Okay, and we know also the attenuation process is represented mathematically by parameter which is called alpha coefficient, attenuation coefficient. This alpha will specify how far the electromagnetic wave will propagate inside the Lossy medium. Okay, so if we know alpha for any medium, we could expect it how far the electromagnetic wave will propagate inside this medium. And we know also if the electromagnetic wave, for example, propagate by alpha, its amplitude will be reduced to what about 36% of its maximum amplitude. Okay, so according to that, if the electromagnetic wave propagate inside any dusy media by what about 3 sigma, or this sigma is called penetration depth. So if the electromagnetic wave propagate by 3 sigma, so that's mean about 90% or maybe 96% of its amplitude will be attenuated or maybe absorbed inside the media itself. And this is very important because according to that we could specify the nature of the interaction between the electromagnetic wave and the medium itself. Okay, the material I mean. And if we know the nature of this interaction, we could specify the application. We could specify if this electromagnetic wave or this electromagnetic radiation is suitable, okay, for this application, is suitable to be processed inside this material. So for example, we could specify if this electromagnetic wave could be used for medical surgery, for example, or for communication, or for cooking, or for industrial process, according to specify the interaction between the electromagnetic wave and the material. And the interaction between the electromagnetic wave and the material is specified if we know how far the electromagnetic wave inside the material itself, like that, sorry, how will we propagate. Okay, that's mean alpha and beta. How will we propagate inside the media and how far will we propagate inside the media.